Use Gauss-Jordan elimination to solve the system 4x minus 3y plus z equals -8, negative 2x plus y minus 3z equals -4, and x minus y plus 2z equals 3. We'll start by writing out the augmented matrix for this system of equations. It'll have entries 4, -3, 1, -8, -2, 1, -3, -4, 1, -1, 2, and 3. Now, we know that we want to get zeros in the lower left-hand corner, but we also want to get ones on the diagonal. And one thing that we can do to help ourselves right away is recognizing that we already have a 1 in this beginning of the third row. And if we switch this with the first row, that will put a 1 where we want there to be a 1. So that's what we're going to do first. We're going to interchange rows A and C. So this will give us 1, -1, 2, 3, -2, 1, -3, -4, and then 4, -3, 1, -8. That just puts us in the right place to have a 1 here already, and that's going to make things easier moving forward. So our next goal is going to be to getting those zeros down there. Now at this point, we're not going to change the first row, so we can rewrite it down here. And to change this -2 into a 0, one of our options is to take row A and multiply it by 2. 1 times 2 is 2, and then add row B to that. 2 plus -2 gives us 0. So that's going to be 2 times row A plus row B. If we do that in the other columns, 2 times -1 is -2, plus 1 gives us -1. 2 times 2 is 4, plus -3 is 1. And 2 times 3 is 6, plus -4 is 2. Good. Now we want to change the 4 into a 0. And what we can do here is we can actually double the second row. We can multiply row B times 2. So that's 2B. When we do that, that gives us -4. And when we add row C, -4 plus 4 is 0. So we can take 2B plus C there. That gives us 2 times 1, which is 2, plus -3 is -1. 2 times -3 is -6, plus 1 is -5. And then 2 times -4 is -8, plus -8 is -16. Nice. Now, I'm going to do 2 things for the next step. I'm going to focus on getting this -1 to change to a +1, and I'm going to focus on getting the other -1 below it to change into a 0. I know I'm doing a couple of steps at once, but the goal is to not have to rewrite augmented matrix after augmented matrix too many times. So we're not going to change the first row. We can leave those entries just as they are. For the second row, to change this -1 into a +1, we just need to multiply this row by -1. So we're going to have -1 times row B. When we multiply those entries by -1, we get 0, +1, -1, and -2. Now we can focus on changing this -1 to a 0. And the way that we can do this is by taking row B minus row C, because -1 minus -1 is 0. So the row operation we'll do is B minus C. Here, 0 minus 0 gives us 0. In the next column, 1 minus -5 is the same as 1 plus 5, which is 6. And 2 minus -16 is the same as 2 plus 16, which is 18. So we're doing really well at this point. We've got zeros where we want them, and we actually have 2 1s on the main diagonal. What we need now is for that 6 to become a 1, and we can do that quite easily. We can take the third row C, and we can divide it by 6. That gives us 0, 0, 1, and 3, and we keep the other rows exactly as they are. And now we've got the zeros where we want them in the lower left-hand corner. We've got the 1s where we want them on the diagonal. And because we're using Gauss-Jordan elimination, we now want to get 1s here, here, and here. And we're going to do them in exactly that order because that is what makes it easiest to do. So, at this point, we're going to move up over here. The third row is exactly how we want it, so we're going to keep it just like it is. But now we want a 0 right here, and we want a 0 right here. So that's going to be our goal for the next step. So to change this into a 0, we can add together rows B and C, because 1 plus -1 gives us the 0 that we want there. So here we're going to write B plus C, and we can do this for the other columns. 0 plus 0 gives us 0. 0 plus 1 gives us 1. And then 3 plus -2 gives us 1. So we're good there. Now we want this one to be 0. And the way that we can do this is by keeping row A here and then subtracting 2 times row C. So it's going to be A minus 2 times C. When we do that, we've got 2 minus 2 times 1, which is 2. 2 minus 2 is 0. Then here we've got -1 minus 2 times 0. That's going to stay -1. Here we've got 1 minus 2 times 0, which is going to stay 1. And then on the right, we've got 3 minus 2 times 3, which is 3 minus 6, which is -3. It's very important to be careful. Once you've got zeros in the lower left and you've got 1s along the diagonal, you have to make sure that any row operations you use don't end up changing any of those entries. So in general, what we do with our A and our B in this step is we just add or subtract a multiple of C, because doing this is only going to change these digits over here. Because we've got zeros here, we know it's not going to change anything in the first 2 columns. All right, so at this point we are almost done, except we have one more entry that we want to turn into a 0. So we're only going to be doing something to the first row, which means we can take the middle and bottom rows and leave them alone. Then for the first row, we want to get a 0 up here. And the way that we can do that is we can take row A and then add row B to it, because -1 plus 1 is 0. So we've got A plus B. If we do that to the other columns, 1 plus 0 is still 1. 0 plus 0 is still 0. And -3 plus 1 is -2. So at this point, we've finished. We've got it in row reduced echelon form, which remember is zeros in the lower left, 1s on the diagonal, and then zeros above the 1s as well. And once we've done this now, we can rewrite this as a system of equations, and we simply have x equals -2, y equals 1, and z equals 3, which is our solution. We can also write it as an ordered triple, so -2, 1, and and 3. Either one of these works nicely as a final answer.